All right, welcome to our right triangle trigonometry unit. Trigonometry is actually my favorite part, I guess, part of math. Whether it's geometry or algebra, whatever, I think you guys will all love trigonometry. It kind of mixes algebra and geometry together, and it's a lot more applicable than most other math that we've been studying this year. So I think you'll really like this. This first lesson, 18.1, is a review. So you've already learned the Pythagorean Theorem, but we're going to be using it quite a bit in this unit. Now, please note, Pythagorean Theorem only works for a right triangle. Nicely enough, however, all the triangles we're going to be studying this year are right triangles. So you'll be able to use it on any of our triangles. So if you've got a right triangle, Pythagorean Theorem just says this. It says a squared plus b squared equals c squared. Now, some people actually teach this, and it might be a little nicer to write leg squared plus leg squared is equal to your hypotenuse squared. Okay, so hypotenuse, remember from your geometry days, hypotenuse is always your longest side, and it's easy to find in a right triangle. It's always going to be the side that's directly across from your right angle. So if you've got your right angle, if you go directly across, there's your hypotenuse every single time. So I kind of always start with C. A and B are just legs. They can switch places. You could call this A and this B, or this A and this B. So please just note hypotenuse has to be C, and then you can use the Pythagorean Theorem. So let's look at these first two examples, and then our next video we'll talk about the converse theorem. But for example number 1, again, biggest thing is to just identify C. So when I'm looking at this lovely example, I'm going to find my right angle, go straight across from it, and call that C. These other two sides, again, doesn't matter, call them A and B, and then you're just going to plug in all these nice lovely values into your Pythagorean theorem right there. Okay, so my a squared, in my case, I put 7 as a. So I'm going to do 7 squared plus b squared. B is what I don't know. My x squared is equal to c squared. C is my 9 squared. All right. Now your calculator, you can actually just subtract 7 squared and your calculator will do it. But just because I don't want you to get mixed up and subtract 7 from 9, let's actually square these first. So 7 squared is 49 plus x squared is equal to 9 squared, which is, I can't decide how to write my 8s, 81 right there. Now we're just going to solve for our x squared. So go ahead and subtract 49 from both sides of the equation right there. It's still equal. And x squared now is equal to 81, subtract 49, which is 32. In your homework, I'm just trying to figure out, I think we're going to just let you round it to the nearest 10th, okay? Instead of trying to simplify radicals, we'll do that next lesson. We're just going to have you round it to the nearest 10th. So when I go to find what x is, I'm going to take the square root of both sides, undo that square right there. So that just leaves me with an x. Go ahead and plug it into your calculator, square root of 32. It might tell you it's 4 squared, it's a 2, and that's a fantastic answer, but we're going to try and get a decimal. So if you just hit that button right above it, it'll give you a 5.656. Let's round it to 2 decimal places. So 6 right there, 5.66. That's the value of that side. Now, note, it should not be, when you get this value, just double check. It should not be bigger than the hypotenuse. Remember, this is our largest side. So kind of just watch that. And then you can go on to the next problem. All right, we're going to do example 2 on this video as well. Example 2 is still using the Pythagorean theorem, but you're saying, where is the triangle? We're going to actually draw a triangle. So we're going to make this into a rectangle and a triangle. Now, in rectangles, you can just go ahead and say this is still going to be a right angle. So we still have a lovely right triangle right here. However, we've got to fill in a few more sides. So rectangles, we know that sides opposite each other are the same length. So if this was x, that side over there is going to be x. So I can still just solve for x. Now, if this side is 5 right here, that means that this side across from it is also 5. So if the whole long thing was 18, remember 18 went from here to here. So if that whole long thing was 18, if I subtract 5 from it, then I know that that side right here is 13. Okay, now I've got my nice, lovely right triangle. I know two sides of my right triangle, so I can find the third side. That's what the Pythagorean theorem does. It gives me a third side. If I know two sides of a right triangle, I can find the third. So across from my right angle, here's my C. Here's, I'm just going to call that A and B. And then we just set it up the exact same way. So we say A, in this case, I called the 13A. So A squared plus B squared, which is my X, is equal to C, or 16 squared. This time, I'm just going to subtract 13 squared from both sides because my calculator does that. So in my calculator, just make sure to square it. 16 squared minus 13 squared, and it tells me it's 87. Okay, double check that your calculator says the same thing. Now, again, we're trying to find just x. We don't want x squared. So you've got to take the square root of that, 87. And I have that it's approximately 9.327, so 3. Right there, there's our x. All right, we'll do the converse theorem in our next video.